This video will demonstrate one way to build a king. This truss will have optimum strength, and the flats on the top and bottom lend themselves to the framing in and closing of the gable end. If this truss were used in a central position, you might consider leaving the bottom of the components round and altering your layout accordingly. This design is very straightforward, and with care it can be incorporated into your double-framed roof system. I have come to classify roof systems as single-framed or double-framed. A single-framed roof has common rafters or rafter pairs that are close enough together to support the rest of the roof material. A double-framed roof has principal rafters, purlins, and common rafters. Most log buildings have double-framed roof support. This does not mean that a single-framed roof is inferior or uninteresting. Indeed, a single-framed roof can, with the right care and good design, be a very suitable structure. Most students realize that the roof is possibly the most important part of a building, and the sooner you can get the roof on your building, the less damage it will sustain from the elements. This brings us back to our original planning and the question whether there were allowed enough time, money, and materials to get the house covered. Once the roof is in place, the builder can relax a little and perhaps take a little time off. It would be very strange if any harm came to the building now. As a matter of fact, a log building can benefit greatly by being left at this stage to settle and dry before finishing. There are at least 5 different styles of roof that are commonly used on log buildings. It is up to the builder to decide on the basis of his skill, material available, preference, and cost. You can choose log gables with ridge and purlins, trusses and purlins, post and purlins, framed gables and purlins, or a raftered roof without purlins, or indeed a cottage roof with no gables at all. Log gables are best suited to a low-pitched roof where settling will be less. Trusses and purlins are beyond question the most elegant style of roof structure, with post and purlins a close second. Trusses do entail extra work, and as such may be considered more expensive. If you are able to do the work yourself and have a good understanding of how to go about it, I do not think that the difference in time and money should cause the builder any worry. Depending on what materials are available, he may be able to build a truss system or a post and purlin roof system out of logs on the site and save the cost of manufactured components. Framed gable ends with log purlins are an old and favored style. The purlins are supported by timbers or multiple framing pieces, not unlike a post and purlin system. The finish can be shakes or any other natural material. In this video, we are going to build a king post truss. But first, let's agree on a few terms. A rafter has rise, run, and length, whether they are principal rafters or common rafters. The cuts are laid out as level or horizontal cuts, and any vertical cut is called a plumb cut. The span of the rafter pair is most often the width of the building. The length of the rafter, L, can be calculated by a simple formula. The length is equal to the root of the height squared plus the run squared. The actual height and run of the rafter may require an allowance for the ridge, purlins, and king post. Subtract the distance d, or a component of the distance, to find the run r and the rise h. Trusses are classified according to their design. It may be a simple truss, that is a triangle with 3 chords. It may be a king post truss with a central post that will hold 2 purlin braces up. It may be a collar tie truss that has a horizontal member about halfway up to support the weight of the purlins, and also a short king post. A queen post truss will be the same as the last, with 2 additional uprights under the collar tie. You might choose to build a W truss, which has 2 king posts and 2 purlin supports, or you might build a hammer beam truss, which is much like a collar tie truss with additional purlin supports. Beyond this, you will be using bridge-type trusses and mechanical components. The other styles named can be made with wood pegs only, or, as is more often the case, with minimal bolt connections. The king post truss in the illustration is a very useful style and can be made quickly. So let's first discuss the building of a king post truss. You will need 5 logs and a tie beam. The tie beam may be the top log off of the gable end wall. The logs might be cut in a mill, or they may be hewn by hand. Prepare the 5 pieces by cutting them just slightly over length, maybe 200 millimeters, and flattening the straightest sides to a thickness of 200 millimeters. Make sure that you don't come too close to the line, and then you can finish with a hand or electric planer. This will be the 2 principal rafters, the king post, and the 2 purlin braces. Place the material on blocks at a convenient height, and if the end lines are not already in place, carefully level the flats and draw these lines. Snap center lines on all 4 sides. On the top end of the principal rafter, place a mark about 100 millimeters from the end. With 2 squares, carry this mark around the log to each of the center lines. If you are working alone, use pins to hold the square in place. Choose which side will be the top and which will be the bottom of the truss leg. It might be a good idea to mark this onto the wood. Our truss has a slope of 1 to 1. Therefore, on the underside, drop back 200 millimeters, or the thickness of the material, and square a line across the work. Now draw a temporary angle as a cutting line. You will now need to know the width of the flat on the top end of the king post, because we are going to make a neat fit at each join. Transfer this width onto the flat sides of the principal and make a preliminary cut. This cut should only be close to the line. Our purpose is to establish a flat surface on which we can draw an accurate line to lay out the top tenon. This line will be a little way up onto the slope of the scarf, but this is still a straight line and much easier to establish than if we drew an arc around the curved side. Lay out and cut the top tenon. Score the plumb line. We have designed this tenon to be 100 millimeters wide and 150 millimeters long at the plumb cut. Cut right on the line so that cleanup is minimal. Do both sides. Use a template to check the size. The template can be made of plywood or a synthetic material, but it should be very accurate. Take care with this template. It's very easy to make the tenon too small or the mortise too large. It is a good idea to have the male half of the template 1 millimeter smaller than the specified size in order to assist in obtaining a tight fit. Cut and dress the tenon to size. The scarf will be finished when the truss has been assembled. You can now lay out and cut the bottom end of the principal rafter. Measure very accurately to the lower end of the leg and do the same layout and cut as we did at the top end. This time the tenon will be 100 millimeters wide and 100 millimeters deep and the full length of the horizontal cut. Remember, when you make the cut at this end of the principal, you will not have an escape opportunity, and your work will have to be accurate. Square this length measurement across the work. Place another line 141 millimeters along for the tenon, and lay out the width of the tenon while you are there. Roll the log onto its side and carry your original dimension line around to the other side and square this across the flat. Measure up 200 millimeters, or the width of the principal if it is different, and place another line across the flat. You can now draw in the diagonal cut lines. Place lines across the end for the width of the tenon and lines on the side for the second cut line. This will bring the material to near the width of the flat on the tie beam, as we did for the king post on the top end. Cut the scarf and the flat, then draw the accurate cut lines for the bottom end. Score and cut this line to complete the third cut. To obtain the most accurate cut, work from each side, then roll the log up to make the cut for the tenon. Do the other side the same way, then check with the template to bring the work to the required tolerance. Square the end of the tenon to the specified length, in our case 283 millimeters from the inside surface. Cut and dress the completed lower tenon. Lay out the mortise for the purlin brace. This should, in most cases, be one halfway along the principal. This mortise will be 100 millimeters by 200 millimeters and only 30 millimeters deep. Its purpose is only to keep the brace in place. Score the lines, then cut the mortise to size, and this piece is complete. Check with the template. We will make the king post next. Square a dimension line around the top of the king post. Be sure that there is enough material left for the length of the post plus the tenon on the bottom. In our example, 2400 millimeters plus 100 for the tenon. Drop back 283 millimeters and place another line for the bottom side of the principal. Bring these lines around to the other side. Check the thickness of the material. The entire piece may be brought within tolerance with hand tools or a power planer, but we are only going to adjust that portion where the principal rafters and purlin braces will seat. Measure from the center line and draw accurate dimension lines on each end. Join these lines with a fine chalk line or ink line. Do the other side. Draw the slope of the principal rafter from the ink line, then square this mark with the center line of the rafter. Score these lines and save the seat to your design dimension, then lay out and cut the mortise at the top of the king post. This mortise will be 50 millimeters deep. Do both sides. Measure the design length of the king post and again square a reference line around the log. Cut the post to length. Remember, you will need extra length for the tenon. Score and adjust the seat width for purlin braces, then lay out and cut the tenon onto the bottom of the post and the mortises for the two purlin braces. Cut each of the two flat sides for the tenon first, then cut the mortise recess. Cut the side portion of the tenon, and after you have checked its dimensions with the template and beveled the corners, the king post will be complete. We now have only to make the two purlin braces and the lower cord or tie beam to have all our parts. Lay out and cut these pieces in the same way that you did the principal rafter and king post. Place the material on skids or horses, wedge the flat side onto a level position, then square a line around the log. In case the procedure for this has been missed, we will go through the details again. Mark the horizontal and vertical center on each end. Draw a level line and a plumb line through these centers. Do both ends of the piece, then snap center lines onto each of the four sides. This is a standard preparation that would be used for most roof parts. Now we will square a line around the log. This line will be at the top end of the brace and need only be a short way onto the log. The final tenon will be only 30 millimeters long, but we have set out about 60 millimeters to make it easier to cut. Place a mark about 60 millimeters from the top end and square this across the log. Do this both ways from the center. Use a sharp pencil to get a thin line. Pin a straight edge to this line, or get an assistant to hold it. Place a square on the line on one side of the log and bring it up to touch the straight edge. Be sure that it is standing vertically. Slide the square back about 1/2 millimeter and place a mark across the center line. Do the same from the other side. Roll the log 180 degrees, then pin or hold the square to one of the side marks. Align your second square with the center line on the top flat and bring it up to touch the square that is pinned to the side of the log. Be sure that the side square is standing upright, then mark and square off the line across this flat. If you roll the log up onto its side, you can use a flexible straight edge to join the three marks and complete the line around the side. Score this line while it's in this convenient position. Roll the log to do the other side, then place it on the flat to lay out the tenon. The tenon is 100 millimeters wide, or 50 millimeters on either side of the center line, but it is 200 millimeters long, the same as the width of the material. So you will be cutting only the two sides. Draw these lines. The specified dimensions should match up very well. Then score the shoulder and cut away the side piece that has been marked with hatched lines. Cut one halfway through from each side. Cut right on the line and be careful not to overcut at the tip of the bar. Roll the log to complete the cut. Again, roll the log onto its side and clean up your new tenon. Do both sides, then lay out and cut the final length of the tenon. It should not be necessary to score this cut. Now check your specifications for the length and measure it onto the center line. Because your line on the other end is accurate, you can measure from that end for all four sides. Drop back 100 millimeters and draw a line around the log. Measure in the width of the tie beam on the end of this piece and cut this flat back to the line you have just made. The slope cut will become the scarf after the truss has been assembled. On the side, come back to your original length measurement and square this off from the center line. Join these lines across your new flat and rejoin the center line. Draw in the angle of the cut. We have already checked to be sure that the material is indeed 200 millimeters wide. Otherwise, we would measure that width on the back end of the flat and extend our cut lines through the intersection. Locate the end cut for the tenon by adding 50 millimeters to your cut line, then cut this out in a logical way. Dress this tenon to size with a sharp slick, and the purlin brace is finished. You can check the width with a template, or it is possible to obtain an accurate fit by close attention to the layout and measurements. You will need 2 purlin braces, and the second one should go very quickly. Check the dimensions of the purlin braces to be sure that they are correct, then make the tie beam. This piece may already have been fitted to the building and acts as a cap log or plate log, or it may be an unsupported tie beam. We will treat it as a tie beam and flatten the top and bottom. Measure the full length of the material and divide this in half to locate the center of the tie beam. It is now only necessary to lay out and cut the 3 mortises in the top and assemble the truss. Lay out and cut the mortise for the king post and braces. These will be 100 millimeters or 4 inches wide, and the position of the king post will be 100 millimeters deep. The purlin braces will be cut 50 millimeters deep. Lay out the cuts by squaring to the center lines. Measure quite carefully, although if the mortise were cut a little too long, there is no great harm done. I would prefer to make the cut as accurately as possible. We now have the length of the king post cut and the additional 141 millimeters for the braces. It's also a good idea to mark the position of the bottom of the slope cut. Carry this to the outside so that it won't be lost. Locate the mortise for the principal rafter by measuring from the center line. This length will be 2,217 millimeters to the inside edge of the cut in our demonstration. The mortise will be 283 millimeters long, 100 millimeters wide, and 100 millimeters deep. Do the same for the other end. Square the work from the center line, then score the cut lines. It is not always necessary to score the length of the mortise, but it will assist in obtaining an accurate cut. You can mark the depth of your intended cut on the side of the chainsaw bar with a felt pen. We are marking both 100 millimeters and 50 millimeters. Another 20 millimeter allowance has been added to each to make up for the round tip of the bar. This way it will not be necessary to do a lot of work on the bottom of the mortise. This kind of plunge cut requires practice. Be very careful to keep your feet out of harm's way. As we have said before, a chainsaw cut is a devastating experience. Try to keep the saw within the lines, and it is a good idea to make the mortise a little narrower at the bottom. Such a cut is easy to fix, but if it is too wide at the bottom, your post will be unstable. If the cut is clean, the wood can be easily broken out of the center. Then the sides should be checked for square. Also check the depth of the mortise. Then make the 2 shallower cuts for the purlin braces. Cut the 2 mortises for the bottom of the principal rafters the same way. Use the line on the chainsaw bar to gauge the depth of the cut. Make the cut square, and be careful that you don't overcut. Use a high chain speed and a gentle, slow saw movement. The sloped end portion will clean up easier if you make several cuts close together. Check that everything is the right size and that the sides are square with the top. Then do the same at the other end to complete this tie beam. All the parts for the truss have been made, and because these parts are heavy, and in some cases the assembly may take place up on the roof, I strongly recommend that all dimensions be checked most thoroughly. If the truss is to be put together on the building, a trial assembly might be first undertaken on the ground. Start by drilling the bolt holes in the king post and the top of the principals. Make a punch mark at the intersection of the center line and the line for the inside of the principal.
Up a little bit. 10.
Drill one halfway from each side, and if you place a small stick in the first hole, it will be easy to line up the drill with this from the other side. The hole in the principal will be at 45 degrees for this truss. Start with the same intersection point, then place a straight edge on the side of the rafter as a visual guide. Start the hole, then check, or have an assistant check your vertical alignment as you complete the drill hole. Use a heavy chisel to pare off and countersink a seat for the nut and washer that will be needed here. The truss is now ready for a trial assembly. We will do this assembly with the pieces lying horizontally on the skids. First, the king post is driven into the mortise on the tie beam. Next, position the principal rafters. Enter the tenons into their mortise, but leave them slack for now. You should have a pair of come-alongs handy for this final fit. Position the purlin braces, and with the aid of the come-alongs, you should be able to drive all the components into place. Finally, drill right through the base of the principal rafter and the tie beam and bolt these together. A countersink attachment for the drill can be useful here. Tighten all 3 bolts to complete the assembly. You may have to use a come-along and a heavy maul to force the components into their seats. These bolts are not necessary after the truss is in place, but they are necessary to lift it into place on the building. Your truss now requires only trimming up to be complete.